Skipper, with Trend Micro, and the topic is defending your workloads against the next zero-day attack. So Craig, I appreciate you joining, and take it away, sir.
All right, thank you very much. So as mentioned, we're going to be talking about defending your workloads against the next zero-day attack. And to that effort, what I'm going to be talking about here is resiliency of the cloud, and the fact that within a cloud infrastructure, as I build these slides out, we're talking about automation. Now, I want to use an example here. I'm going to start off with an example and then talk about the different ways that you could deal with those particular threats. So we know that systems all have vulnerabilities, and one of the big ones, or one that was out there, was the Shellshock vulnerability. It was basically a vulnerability that was using the bash, which was a common command line interpreter across many, many devices, using bash to basically break into a system. It was very easy to do, very simple. In fact, if you see in the lower left-hand corner here, the 10 out of 10, that shows that it was 10 in terms of ease of use, and 10 in terms of how powerful the particular exploit was. Now, the attack itself required very, very little code. Normally, I wouldn't show particular code, but this has been out there for a while. There have been patches for it, and at this point, it's pretty much a taken care of particular vulnerability. But you can see just these little lines of code from the A to the bracket toward the end. That's all you would need to essentially exploit a system. And by simply running that command, you could easily be able to open up a system, get access, pull basically any type of information you wanted from that system. Now, this little clock here is representative of the idea that the actual bash Shellshock vulnerability had actually been in the code since 1989. So this particular vulnerability had existed in the code since 1989. And so you think about the year of 1989, right? Gas was extremely inexpensive. It's not too expensive today, but it's definitely not 97 cents a gallon. And you can see from the timeline here, this is the code itself of bash when they, in terms of check-in to that official code was released, and it was sitting in that code base for 9,141 days before even a notice was taken, and then patches were applied. And so if I kind of let this scroll on by, you can see we had an initial patch that was pretty quick, and then there was another patch that came out later. So even that first patch didn't take care of it. And then there was another set of patches that came out. So from a timeline perspective, not only was that vulnerability sitting in the code for since 1989, but that was also that was sitting in the code. It took about 5 different patches to actually fully lock down that component and prevent it from being exploited. So if you were on that initial run, which got the initial notice, you applied that first patch, and then after you applied that first patch, you then 9 days later had to apply another patch, and then 4 days later you had to apply another patch, and then another day later you had to apply another patch, and then 2 days later you had to apply another patch. Now, that's a lot of patches. That's a lot of processes to go through. So I'm going to be talking about two different approaches: react and resolve. The first item here is you need to be able to proactively react to that. When you're talking about reacting, we're talking about making sure your roles within your environment are applied. Security groups are set up properly. Networks are segmented. And as part of that, you have to consider the fact that you're going to be dealing with a lot of different traffic that's coming along. And so you need to have tools that are able to analyze that traffic. The bash vulnerability in particular was a vulnerability that was remotely exploitable. So when you think about it, you want to make sure your HTTPS traffic coming across is valid, right? Is it valid HTTPS traffic? But not only that, you want to make sure that the traffic is not like SSH, for example, and even when it is valid traffic, that it does not contain additional exploits. You can see that SQL injection. So, you know, making sure all those instances that you have running in the cloud are basically protected, that you have workload-specific rules, meaning you've got the ability to identify the traffic with intrusion prevention capabilities, and not necessarily doing those intrusion prevention capabilities out at a perimeter, because when you talk about the cloud is really about having each individual instance, you know, although behind, you know, firewalls, you can say that the various providers, cloud providers, have your basic level, usually basic level firewall functionality, but having that capability and then being able to, in addition, centrally manage that capability. You can see at the bottom here, 2 different cloud providers, not the only cloud providers, but there's best practices guides and security checklists that they provide to their customers to help them secure those environments. Now, the other aspect is the resolve, and this is where things actually, in my opinion, get a little more interesting. Because when we're talking about reacting and providing intrusion prevention and those type of capabilities for, say, vulnerabilities, to defend against sort of 0 days, because usually a 0 day is going to come in through some type of vulnerability. Not always just a vulnerability, but definitely that's one key area, is being able to look and make sure that you've got a particular setup in your environment that is conducive to that. So with the whole point of a 0 day is the fact that it is unknown. So it's not like you have a signature for it that identifies the particular type of 0 day attack or something along those lines. Yes, we can identify a vulnerability used by that, and that's a good thing. But you also need to have a configuration or a setup in that cloud environment that really provides a means to quickly identify new threats without having to know all of the details. So if you have not heard of it before, there's a notion called a blue-green or green-blue, I think I've heard it both ways, deployment. And this is going to be a build-out slide here. But what you're going to have is you're going to have a production environment running. And then there'll be times where you'll need to make changes and test. But then the idea of a blue-green is that you have all that data off in the green deployment. The green deployment is going to be your production, and ultimately you want to make sure that as you have systems running in that blue deployment that are up and running successfully, you're going to test, you're going to do these various 1, 2, 3 step process, and then when you promote it, ultimately what that's going to do is that means that you can go back in and destroy those previous instances, because now those instances are no longer necessary and you've basically got a new production. So the principle behind that is the idea that you have 2 different deployments. One you use to test everything out, make sure it's functioning, apply, that's where you'd say apply patches, make fundamental configuration changes, things like that. And then you'd have another deployment that's always running and available. And so the always running and available deployment, the idea is that you don't make any changes to that deployment out in production. You're actually making the changes behind the scenes, and then you promote those systems to production. So that gives you a fundamental advantage in terms of the types of tools that you can use. So those types of tools that I'm referring to, for example, is integrity monitoring. That's one possible tool, but this is a particular tool that's extremely powerful. And the idea there with integrity monitoring, I think as we all know, but I'll just briefly lay it out at its fundamental basics, is you want to look for changes in the environment, unauthorized changes. And if there's an unauthorized change, you want to know, you want to be alerted, you want to be able to look at it and take action. The advantage with a blue-green deployment is the fact that if you're running those integrity monitoring tools in that production, up and running out there in the world environment, then you're going to be able to note that, hey, any change to that environment, any fundamental change from an integrity perspective is a bad thing. There shouldn't be any configuration change. There shouldn't be any adjustments. The whole change management approach means that you have the flexibility to be able to note that if there is a change out there, it's something that needs to be investigated. Now, it could have been because somebody didn't follow the procedures, the change management controls, and actually touched a production instead of changing on the back end and then promoting. But the advantage there is that if you're having that model in place, once you get that laid out, like I said, any change out there can alert you to a problem, and any piece of exploit or something is going to make some fundamental change somewhere to the system, to a file, to folders, to say registry, other areas, and you will then need to go in at that point saying, hey, there shouldn't have been a change here, something's going on. You may not know exactly what's going on, but it's that kind of early warning, it's the canary in the coal mine that says something's not right here. So again, to really bring it back full circle, what we've got is we've got this notion of react. So again, reacting is reviewing those configurations, taking those proactive steps to say, do we not have things set up, or I should say, do we have things set up in the right way? Are we in a situation where we have the right systems able to talk to each other and also only talk to each other? Do we have things set up such that the back-end database, so if you're thinking about a tiered infrastructure where you have web applications on the front end, databases on the back end, do those databases have access just to the front end web server, or somehow has somebody made access to the world available to those databases? If that's the case, then you go, well, we really don't need those databases to have access to the world because people are accessing the data in those databases via the web server. So controls in place that really are operationally efficient. And then the real-time controls of intrusion prevention. So when we talk about intrusion prevention, we're just talking about understanding, hey, there's these vulnerabilities that have been identified, or maybe there's traffic normalization, being able to make sure the traffic coming in is properly normalized, that it's not out of sync. Often many attacks give themselves away by sending packets out of sync, things like that, or opening connections, like a DDoS, opening a connection and never closing it so that ultimately your server falls over, being able to identify those aspects. And then the resolve aspect of it, being able to look at those operational techniques again, dealing with the green-blue deployment, using that as a fundamental standard in the cloud. This is a very easy thing that you can do in the cloud. In fact, the cloud provides the tools now that give one the flexibility to do that type of deployment that maybe was not a capability or resource contention if it was only internally. And then finally, the real-time controls of integrity monitoring. So once you have set those operational techniques in place with a green-blue deployment, you can then leverage the integrity monitoring tools to be able to identify any changes and note that, of course, any changes to that production environment are essentially bad changes, whether by accident or whether by purpose. In any case, it's something to be investigated, and you now have the power to be able to do that. So I want to thank you again for listening in, and hopefully you've learned some techniques here that you can leverage. At this point, I'll turn it back over.
Awesome. Thank you so much, Craig. At this time, we'll open it up for questions. As a reminder, if you have any questions about today's session, please post them to the questions pane in the GoToWebinar control panel. We do have a couple to get through and a few minutes to get through them. So let me just check that out. First question, Craig. How can you defend against more advanced attacks when the vulnerability and or malware used are equally unknown? That's a great question.
Yep, that is a good question. So if they are both the malware and the vulnerability are equally unknown, that's where tools like the integrity monitoring. Obviously, if the vulnerability is unknown and if it's not abnormal traffic, then you're not necessarily going to detect it with intrusion prevention capability. However, if you're leveraging, say, a green-blue deployment mode, then your integrity monitoring would be able to pick up any fundamental changes to the system, which could lend itself to there being a particular threat in the environment. Obviously, the whole thing about unknown is it is unknown, and so you're not necessarily going to be able to identify its threat XYZ. However, leveraging that green-blue deployment, leveraging integrity monitoring tools will actually give you the keys to know when you should look, and then of course when you do that further investigation, at that point you will most likely, through that investigation, uncover a particular attack.
Excellent, thank you. One more question, we've definitely got time. With the loss of visibility from a security perspective, as environments move to cloud infrastructures, how can we keep on top of the dynamic nature of those environments to know which machines are secure, which need to be secured, and which machines are no longer up and running? That's a great question. I think the distributed workforce is a huge issue right now. So if you can speak to that, that would be great.
Absolutely. So yeah, that is a fundamental issue with moving to the cloud. And I say issue in the lightest sense because obviously there's a lot of power that we can get by moving to the cloud in terms of flexibility and growth and those type of things, as well as cost effectiveness and those aspects. But when you move to the cloud, you really do need to have a mode of visibility into that. Yes, you get access to visibility through the native tools of the vendor, whether it's AWS, Azure, vCloud. Again, there's a number of different cloud providers. However, not having that visibility outside of those tools can be a detriment, because at that point you're depending on those tools, and if you, as say a security admin, doesn't have access to a particular user in the environment and their ability to spin up or spin down machines, you're essentially blind. Now, this is where I'm actually going to talk about a technique and then actually reference a trend in this, is that there is a technique that you can use cloud connectors to be able to get visibility into those environments. Trend Micro does such a thing where essentially we're able to connect into the cloud provider, and then we're able to enumerate the inventory of all the systems in that cloud environment. So all we need is a basic level access to that environment, and then we can let the security admin know, here's all the machines running. We're not taking control of those machines. The individual who is spinning them up and spinning them down can still do so at their whim, but then the security admin will then know, hey, I can see all these systems in my security console. I don't have to go over and ask permission to get access here. I don't have to, try to ask them, hey, have you spun up any new machines today? I can simply have that access in my own security console. And if I see something is insecure, I can go ahead and take action. And that feature and capability is really good because it can provide that visibility. It's great for doing audits. You'll be able to know when machines are actually running, when they're not running, whether they truly exist or if they're no longer out there. And that level of visibility is really important from a security perspective because, again, often the operations team will spin up systems and not necessarily tell the security team. And if it was a traditional data center, usually there's a level of visibility, but if it's in the cloud, again, you lose that. So having those type of tools can be extremely effective.
Excellent, thank you. That actually concludes our questions for today. Thank you everyone for your time and attention, and of course to our guest speaker, Craig Skippers from Trend Micro. Great information, obviously.